Good evening, everyone. So, as scheduled for today, we are going to see the theory part of the chapter electrochemistry, right? So, this is NCRT chapter 2, electrochemistry theory part 8. So, let's start. Disclaimer: the images, text, and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using the generative AI, which is experimental. So let's start with the today's objective, which is after attending this lecture, you will be able to, first of all, describing the fuel cells, and then you will be able to explain the corrosion as an electrochemical process. Corrosion is a process or chemical process, you can say. So after attending this lecture, we can do this both. Okay. So we have studied till now in our previous lectures regarding the different type of cells, their reactions, their representations, about the redox reaction, about the Nernst equation, about the Colrosh law, right? And about the batteries in the very last lecture. Now here we will cover the fuel cells in detail. So what are the topics which we are going to cover today according to the NCRT? So first is the section 2.7, which is fuel cells. In this, we will study first of all the structure of the fuel cell, that how we built the fuel cell, what is the structure. Then the cell reaction. Then the corrosion part. Okay, corrosion is mentioned as the section 2.8, and corrosion. In the corrosion, we will first of all study about the corrosion reaction, that what is the corrosion process and what is the reaction under the process of corrosion. Then we will talk about the methods of preventing corrosion. Okay. And then lastly, we will cover some in-text questions, which is marked as 2.13 to 2.15. That means 3 in-text question, 2.13, 2.14 and 2.15 in this lecture in the ending. Okay. So let's start our first topic, which is fuel cells. Okay, which is marked as 2.7 subsection. And the fuel cell is the first topic of today's lecture, and in this, production of electricity by the thermal plants is not a very efficient method and is a major source of pollution. So first of all, we are talking about the use of fuel cell. So basically, if you see that the production of the electricity, right, the electricity production, that means how we made or how we produce the electricity in the thermal plants. Thermal plants are big industrial plants in which the electricity is made up, and the production of the electricity is carrying on for the supply or for the larger supply to the larger area. Okay, so the production of electricity by the thermal plants is not a very efficient method and is a major source of pollution, right? Also, that as it is not a very efficient method and it is also a major source of pollution, a lot of pollution happens due to this. Okay, so as I was saying, that the fuel cell, we are studying about the fuel cell. Okay, so the production of electricity by the thermal plants is not a very efficient method and it is a major source of pollution. So I was saying that when you observe that in the very big thermal plants, for the larger production of the electricity, this is not a very efficient method of the production of the electricity, and also it causes many pollution. We know that a galvanic cell directly converts the chemical energy into the electricity, and it is highly efficient. So, a galvanic cell we have studied very before. So, the galvanic cell directly converts the chemical energy into the electricity, and it is highly efficient, right? So, the work of the galvanic cell, the concept of the galvanic cell was on this basis that it converts the chemical energy of the redox reaction, which is happening inside the galvanic cell, between the electrode and the cathode, between the anode and the cathode, right? So, chemical energy conversion to the electricity by the galvanic cell is an efficient method for the production of the electricity. So, galvanic cells that are designed to convert the energy of the combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy are called fuel cells. Okay, so galvanic cells, those galvanic cells that are designed to convert the energy of combustion of fuels. Okay, so we particularly or specially design some galvanic cells for converting the energy of combustion of fuels. We use the fuels in the galvanic cells for their combustion, okay, for their proper combustion, and whatever the energy of that combustion reaction will produce, that we will use to produce the electricity. Okay, and we use the fuels in the galvanic cell like hydrogen, methane, methanol, etc. Okay, and we do this combustion reaction of the fuels in the galvanic cell, and then whatever the energy we will get after this combustion reaction, we will use it to convert it into the directly into the electrical energy, and these type of galvanic cells are known as fuel cells. Okay, fuel, as already present in the name, fuel means something which we are combusting, which we are doing the combustion process with it, and also the energy which we are getting from the fuel that we are utilizing at somewhere, okay, in positive way. So here the name, as the name already had fuel, that means in this cells we are using the fuels like hydrogen, methane and methanol. Okay, hydrogen means H2, methane means CH4, and methanol means CH3OH. Okay. One of the most successful fuel cells uses the reaction of hydrogen with the oxygen to form water. So the most successful fuel cells, one of the most successful fuel cells use the reaction of the hydrogen with the oxygen to form the water. Basically the combustion reaction of the hydrogen with the oxygen to get the water as a fuel. This is the most used, or you can say most successful fuel cells in which this reaction is going on between the hydrogen and the oxygen to get the water as a product. The cell was used for providing electrical power in the Apollo space program also. So in our, in our space engineering also, we use different cell to provide the electrical power there, okay, from the combustion of different fuels, because that's the only method to get the fuel or the electrical power in those space programs. So one of the space program name is already written, like Apollo space program, where the cell was used for providing the electrical power. Now let's talk about the structure of this cell, which is fuel cell, which is our section 2.7 in our NCERT textbook. So the water vapors which are produced during the reaction were condensed and added to the drinking water supply for the astronauts. So astronauts are the pupils, who work in the spaceships or, in space related matter. So who travel in the space, you can also say. So water vapors which we get or which are produced during the reaction of the fuel cell, they were condensed. Condensed means, okay, now condensation is a process. Condensation, okay, condensation is a process where we apply a large pressure, or you can say we convert the gaseous state to the liquid state. Okay, so what we are saying that whatever the water vapors we are getting during the reaction of the fuel cells, they were condensed. We condensed them. That means we apply the pressure to convert those gas to those water vapors to the liquid and add it to the drinking water, and we use that liquid as a drinking water in the spaceships by through the astronauts. Okay, so because as I said that in the astronomy or in the space we have so many lack of things, right? We can't take everything because when we travel in the space we don't have anything from the earth. We can have a limited supply of the things which can we bring from the earth with ourselves. So as I said that these fuel cells, some of the fuel cells also used for the electrical power in the spaceships, right? In the spaceship programs. So also whatever the fuel cell we are using and whatever the reaction is happening in those fuel cells, the energy or the water vapor, the energy which is producing from that, we are converting that into the electrical power, and as electrical power we are using them to accelerate or to for the functioning of our spaceships, right? But also we can one more use is that whatever the water vapors we are getting from the reaction which is going on in those fuel cells, we can also use them as a drinking water by the condensation of those water vapors, right? So we condense them and we add them to the drinking water supply for the astronauts. In the cell, hydrogen and the oxygen, that means H2 and O2, are bubbled through the porous carbon electrodes into the concentrated aqueous sodium hydroxide solution. Now, here we are talking about something like structure of the fuel cell, right? So, in the cell, the hydrogen and the oxygen, they are bubbled, okay, they convert in the bubble form through the porous carbon electrode. We have a porous carbon electrode. Porous means the electrode is having so many pores in it, okay, space, empty space in a circular way, or you can say empty space through which anything can pass, okay, a smaller thing can pass. So the electrode is of carbon and also it is porous, through which the hydrogen and the oxygen are bubbled in the cell, and the carbon electrode, the porous carbon electrode, into concentrated aqueous hydroxide solution. Now this hydrogen and oxygen traveled in the bubble form through the porous carbon electrode to the concentrated aqueous sodium hydroxide solutions, NaOH, concentrated NaOH solutions. Okay. Catalyst like finely divided platinum or palladium metal are incorporated into the electrodes for increasing the rate of the electrode reactions. So we also use the catalyst in these type of fuel cells because the functioning of the fuel cell or the greater rate of the fuel cell is very important, because as I said that the use of the fuel cell involves the production of electricity in the large scale in the thermal plants, right? And also in some spaceships programs like Apollo spaceships programs. So a catalyst or a higher rate reaction should be, if we can provide, it should be there in the fuel cells. And for that, what we can use the catalyst for accelerating the rate of the reaction. So catalyst, what kind of catalyst we use? Like finely divided platinum, PT, or palladium, PD metal. They are incorporated into the electrodes as a catalyst for increasing the rate of the electrode reaction. Increasing rate of electrode reaction means whatever the reaction is happening on the electrode, that will increase, their rate will increase, their time duration in which they are completing the reaction, in which they are converting the reactant to the product, that rate, that time will increase. That means that the rate of the reaction will increase by using the catalyst like finely divided platinum or palladium metal. So this is figure marked as 2.12 as per our NCERT textbook, which is the representation of fuel cell using the hydrogen and oxygen producing electricity. Okay, so this is kind of fuel cell. You can see we have this brown space which is aqueous electrolyte. Okay, electrolyte, until now you have seen that in every cell we have some type of electrolyte present in our cell. Okay, for the proper you can say relation or connection between the two electrodes, anode and the cathode. Right. So here also we have this green one is anode having negative charge. Purple one is the cathode having positive charge. Okay. We have some you can say spaces provided for the inserting and the outward in the outward and in the inward direction for the either the insertion or the taking out of anything. So if you are saying if you are seeing that here and through this entry we are adding the hydrogen, and through this entry we are adding the oxygen gas, right? And after the reaction between the electrodes or on the electrodes, the output we are getting by the combustion of hydrogen and oxygen is water through this fuel cell. Okay, so fuel cell as a product water is we are getting from this cell. Okay, so this is a fuel cell in which we are using hydrogen and oxygen to produce the electricity. This is the structure of the fuel cell. Now let's see the cell reaction of the fuel cell. Okay, so what is the reaction which is actually happening or which is actually going on in the fuel cell? The electrode reactions are given below. Electrode reaction means whatever the reaction is going on the particular electrodes. On the cathode, oxygen is reacting with the two molecules of the water and gaining 4 number of electrons or 4 number of negative charge to become or to produce 4 hydroxyl ions, 4 OH negative in the aqueous medium. So this is the reduction process happening on the cathode electrode. Meanwhile, on the anode electrode, we have hydrogen, 2 molecules of hydrogen combining with the 4 hydroxyl ions which it is getting from the cathode, and when they are combining, the anode is producing 4 molecules of water and 4 negative charge, that means 4 electrons. So this is the oxidation process which is going on the anode. If I if I revise you the concept of the cathode or anode or reduction or oxidation process, reduction involves the gaining of the negative charge or gaining of the electron, while oxidation involves the losing of the electrons. Okay, so basically in the oxidation, generally oxidation happens on the anode in most cells, and reduction happens on the cathode. Okay, and in the oxidation, the electrons which are releasing are at the product side. That means at the right side of the right arrow. This arrow at the right side of this arrow, in the oxidation process there will be electrons, and at the left side of the arrow we have electrons while in the reduction process. Okay, so at the cathode, that's why I am saying that at cathode the reduction is happening. Reduction is going on, reduction process, because the 4 electrons are present at left hand side of arrow, and at the anode oxidation process is going on because at the right hand side of the arrow the 4 electrons are present. So these are the electrode reactions of the fuel cell. Now overall reaction being, so for the overall reaction we just add these two reactions going on the electrodes, and the overall reaction we are getting is 2H2 from this plus O2 from this, giving us 2H2. So this is the overall cell reaction. That means not the particular electrode reaction like here. This is overall cell reaction. That means if you are giving the cell hydrogen and oxygen, the cell will return you molecules of water. Okay, so how we just how just describe or how just derive this overall cell reaction, we add the cathode and the anode reaction. So this hydrogen, this water molecule is here also, 2 water molecule, and here we have 4 water molecule. When you add them, so the 2 water molecule will get cancel out, okay, and 2 will remains. Similarly, the 4 electrons are present here and the 4 electrons are present here. That means at the left hand side and the right hand side of the arrow, we have 4 electrons, so they will also cancel out, because you can't, cannot, or you have added the 4 electrons and you are getting the 4 electrons, so this will not included in the overall cell reaction. Okay. Also, we have 4 hydroxyl ions here, 4 hydroxyl ions here. That means at left hand side and the right hand side of the arrow in the final reaction. So that will also cancel out, because we are adding the 4 hydroxyl ions in the reaction and we are getting the 4 hydroxyl as a product. So that means it will not participate in the overall cell reaction. The remaining, that means oxygen, 2 molecules of hydrogen and 2 molecules of the water molecule will be present in our overall cell reaction. Okay. The cell runs continuously as long as the reactants are supplied. Okay. We have seen the structure of the fuel cell where openings were there. From the 2 openings, the oxygen and the hydrogen are going inside the fuel cells, right? Inside the fuel cells, and one opening through which the water molecule is coming outside as a product of the fuel cell, right? So this, what are we saying? That cell run continuously as long as the reactant are supplied. If you see the overall cell reaction, reactants are hydrogen and oxygen, which you can supply from the external source, from the external from the external phase to the inside of the cell. That means as long as you will provide the reactants, the cell will run continuously, the cell reaction will going on, the product you will get. Okay. So fuel cells produce the electricity with an efficiency of about 70% compared to the thermal plants, whose efficiency is about 40%. Now if you compare, the fuel cell is a better option for the production of electricity, because fuel cell produce the electricity with an efficiency of about 70%. If you compare it with the thermal plants electricity which we get, whose efficiency is only about 40%, and also we have a lot of waste and the pollution we generated while the generation or the production of the electricity through the thermal plants. So we suggest that always we have to consider the fuel cell for the production of the electricity, because it can have many uses. Also it's side products can also we can use by in different way. One is just discussed, that the water vapor which we get from the reaction which is going on in the fuel cell, we can use it after the condensation process of that for a drinking water for the astronauts, right? So there are many uses, and also the good efficiency of electricity, which is about 70% in the fuel cell case. Compared to the thermal plants, it has only the efficiency of 40%, which is really low. And also there will be a lot of negative point like pollutions and the waste. Okay. Okay, now let's move to our next section, which is marked as 2.8, and it is corrosion. Okay. So in the corrosion is basically a chemical process. We relate the corrosion as a chemical process. Mainly happens with the iron metals. Okay, so let's explain it. Corrosion slowly coats the surface of metallic objects with oxides or the other salts of the metal. So what we are saying, that corrosion slowly coats the surface of metallic objects. So it happens on the surface of the metallic objects. So it will, you can say, it catch up the whole area. Okay, it flow out and it coats over the surface of the metallic objects like iron with oxides or the other salts of metal, and it contains the oxides or other salts of the metals. Rusting of iron is a very common example. Tarnishing of silver, development of green coating on the copper and the bronze are some of the examples of corrosion. Okay, so these are the examples of corrosion. Tarnishing of silver means silver will become black with the time if you put it in the air. Okay, So development of green coating on the copper and bronze. In the previous time, in the older time, we have copper made up of taps in the homes, right? So if you notice, there will be a green color coating over that taps or even the copper bottle which comes. After some time, the copper will cover with the green coating. Okay, so these all processes involves the corrosion process, and these are the examples of corrosion. It causes enormous damage to the buildings, bridges, ships, and to all the objects which is made up of metals, especially that of iron. And as you know, iron we use very, very significantly in our daily life, right? So whatever the object is made up of, like whatever object is made up of iron, so if the corrosion will happen, if the corrosion will process will catch up those objects, it will cause enormous damage. Okay, buildings can form of iron, like we use irons in the windows, in the doors, like in the handles, in the pipings also. So buildings can damage through this corrosion process. Bridges can damage, which is made up of iron mostly. Ships can damage, which is also made up of alloy but also iron. And to all the objects of the metals, to all the objects which is made up of metal, especially from that of iron. In the corrosion process, a metal is oxidized by the loss of electron to the oxygen and formation of oxides. As I said, that generally corrosion happens when the things or the objects made up of the metals are placed in the open area or in the normal air, in the contact with the air, right? So in the corrosion, what happens? The metal will oxidized. Okay, oxidized means it will lose its electrons. So it will oxidized by the loss of electron, and to whom? To the oxygen. It will lose its electron. Metal will lose its electrons to the oxygen, and formation of oxides. Oxide will form for the metal. Metal oxide will form on the surface of the metal because metal has just lost its electrons, right? So this is the process that in the corrosion this is happens. Corrosion of iron, commonly known as rusting, occurs in the presence of water and air. If the surface of the iron comes in the contact with water or air, the corrosion will happen. Okay, the corrosion process will take place. The chemistry of corrosion is quite complex, but it may be considered essentially as an electrochemical phenomena. And why we are studying it, corrosion, that means corrosion in this chapter, electrochemistry, because first of all, its chemistry is quite complex. You can't understand the corrosion in every process, but it may be considered essential as an electrochemical phenomena. This is an electrochemical phenomena. Okay, that's why we are considering as essential point in this chapter. Corrosion reaction. So corrosion reaction is our next topic, which we are going to study under the section 2.8, which is corrosion. If you talk about the reaction, in this chapter, whatever the reaction we have seen its first of all anode reaction and cathode reaction. That means electrode reactions. Okay. So first of all, we see the anode and the cathode reactions, and then we will see the overall cell reaction by adding the anode and the cathode reaction. So corrosion reaction, the anode reaction of the corrosion is that two Fe metal atoms, okay, in the solid state, they will lose its electrons, become 2Fe2 positive, become ionic, and lose its 4 electrons. Okay. The standard potential of this process is minus 0.44 volt. Now, on the cathode, the reaction happening is that oxygen is combining with the 4 protons and also gaining the 4 electrons which are lost by the anode. Okay. And cathode, we have water molecules production. Okay. By the combination of the oxygen, 4 protons and 4 electrons. Now, overall reaction for the corrosion will be the sum of these two reactions. So let's see. Overall reaction involves the two iron metal atoms plus the oxygen in the gaseous form plus 4 protons in the aqueous form. So this much, this one, and this one, right? They will add up because this will cancel out, okay, and the remaining will also add out. So at the product side, we will get 2 iron, 2 plus ions, and 2 molecules of the water. Okay, so this is the overall reaction of the corrosion. Okay, continuing on this topic, the ferrous ions which we are getting are further oxidized by the atmospheric oxygen to the ferric ions. The oxidation will, again happen because that is the main cause of the corrosion or rusting of the iron. That metal lose its electrons. Okay, the metal will become the iron. Let's say is X positive plus X electrons. So metal will lose its electrons and lose its electrons to the oxygen and form the metal oxide, right? So the ferrous ions which we are getting after the oxidation process once will get further oxidized. This oxidation process gets going on because the metal surface is in contact with the atmospheric oxygen, right? So the ferrous ions further oxidized by the atmospheric oxygen and become ferric ions, that is Fe3 plus. Okay, which come out as rust in the form of hydrated ferric oxide, which is Fe2O3.H2O. This is the formula of the rust. As I said, rusting. Okay, rusting is a process. Rust is a product which we are getting after the rusting of the iron. Okay, so as it is written, that which comes out as rust. So after the further oxidation of the ferrous ions to convert into the ferric ions, we will get rust as a product in the form of hydrated ferric oxide, which is Fe2O3.XH2O. And with the further production of the hydrogen ion, we also get the further hydrogen ions. You can see this figure, which is marked as 2.13, showing the corrosion of iron in the atmosphere. So this is the iron surface, the silver one. Okay. Now the metal oxide which is forming is Fe2O3 here. Okay, and the reactions are showing that how the reactions happen. So oxygen, this atmospheric oxygen reacts with the humidity, or you can say moisture of the atmosphere, that means the 4 protons, and convert to the 2H2 plus, right? Then the Fe which is present, Fe metals, or you can say Fe atoms which are present inside the Fe metal, they will release 2 electron and become Fe2 plus. Similarly, like this, Fe release 2 electrons and become Fe2 plus. Now this Fe2 plus reacts with the atmospheric oxygen and forms the metal oxide like Fe2O3. Okay, now there are 2 electrons which iron has produced. These 2 electrons gets combined, become 4 electrons, and also release the, or you can say they are present as free electrons on the surface of the metal for the further reaction. So oxidation which is happening is iron converting to the Fe2 plus ferrous ions and producing 2 electrons. Similarly, the reduction which is happening is oxygen reacting with 4 protons, which is this one, and 4 electrons. These 4 electrons which we get after the oxidation of the iron atoms. Okay, so they will these 4 electrons will attach or will react with the atmospheric oxygen and 4 protons and become 2 molecules of water. And the atmospheric oxidation, which is kind of the overall reaction which is happening, is 2Fe2 plus 2H2O plus half of O2, which is giving us ferrous oxide. That means the metal oxide. Okay, metal here is iron. So metal oxide, ferrous oxide plus 4 protons we will get. Okay, so this is the 4 protons which we have added as a moisture from the atmosphere. we are getting it again back in the final process. Okay, so this is the overall corrosion of iron which happens in the atmosphere and their respective reactions at like at anode, which is for the oxidation, at cathode, which is for the reduction, and the overall cell reaction, which is atmospheric oxidation, or you can say overall reaction of this process. Okay, and through this diagram you can easily understand that what's the total process which is happening, because you can see the this mantle surface is of made up of iron, which is releasing two number of electrons. Each atom is releasing two number of electrons and converting to iron ion Fe2 plus, and these Fe2 plus will join or will combine with the atmospheric oxygen and converts to the metal oxide like Fe2O3. Okay, and these two electrons in the pair become 4 electron, and they are using by this oxygen reaction with the hydrogen ions and becoming or forming two molecules of water. So this is the overall reaction happening for the rusting of iron, or you can say for the corrosion of iron in the atmosphere. Now, let's talk about the methods of preventing the corrosion. How can we prevent the corrosion process? Because corrosion process is not good. It can cause the damages to our various objects, buildings and instruments and many things. So, how can you prevent the corrosion? There should be any method, right? So, prevention of corrosion is of prime importance, as I said, because it can cause the various damages to the various things, important things, or the things which we, put within the contact with the atmospheric oxygen. Everything we can't protect, right? Everything we can't put in a room. Something should be there in the open area or with the contact of atmospheric oxygen, right? Like bridge and the buildings, right? But the prevention of the corrosion in that case is of prime importance. It not only saves money but also helps in preventing the accidents such as bridge collapse or failure of a key component due to corrosion, right? So bridge collapse happen due to the corrosion because the older bridge, that's why we said that don't travel or don't walk on the older bridges, because maybe it it get corrode, it get corrode and also can collapse in the future time. So that's why uh, the major issues it can cause is like bridge collapse or the failure of key components which made up of the metals, okay, and which cause the corrode or which corrode with the time. So how can you prevent all these? So one of the simplest method of preventing the corrosion is to prevent the surface of metallic object to come in the contact with atmosphere. So as I said that everything we can't put in the room. Some things should have to be inside. Something should have to be outside, right? In the open atmosphere. Like bridges. Bridge is a most like familiar example. So simplest method is that you don't put the metallic objects in contact with atmosphere. Okay, simplest method is that. But this can't be possible in every case. So this can be done by covering the surface with the paint or by some chemicals. Now, the alternative thing is you can protect the metallic object to come in the contact with the atmosphere. You can paint the surface of the metal by some another chemical. Okay, you can paint the surface of the metal, or you can say this is a process of covering the surface of the metal to come in contact with the atmospheric oxygen, to just paint it by some chemicals. For example, bisphenol. Bisphenol is a compound which we use in paints, and also a low quality bottles made up of is bisphenol. Bisphenol structure, if we talk about two benzene rings are joining together. Okay, two benzene, or you can say two phenol rings are joining together, and here we have two methyls. Okay, this is the structure of bisphenol. So this we can use to paint the surface of the metal, to prevent it or to cover it, to prevent it from the contact with the atmosphere. Now, another simple method is to cover the surface by the other metals. Okay, by other metals like tin, zinc, etc., that are inert or react to save the object. Okay, that means we can also cover the surface of our metal by some other metals which are inert. That means they generally don't react, or they will not react with oxygen or any kind of another thing. Or if they react, they will save the object. That means they will react differently with the oxygen, that they will in the final they will save the process or save the surface of the metal. So we can also cover the surface of the metal by such type of metals. So the example include the tin and the zinc. An electrochemical method is to provide a sacrificial electrode of another metal like magnesium, zinc, etc., which corrodes itself but saves the object. Now, electrochemical method. Okay, electrochemical method we have already studied. Electrochemistry we are also studying. So, electrochemical method is to provide a sacrificial electrode of the another metal, for example, magnesium, zinc, which corrodes itself but saves the object. Or if the object size or the metal object size is smaller, we can also provide the electrochemical method by providing a particular electrode which made up of another metal from the metal which the object is made up of. Okay, so the electrode metal can be magnesium, zinc. Okay, what will happen? This electrode will corrode itself. The corrosion will happens with this electrode, but it will save the metal. Okay, this is also a process to prevent the corrosion. Okay, now let's do a in-text question which is 2.13 as per our NCERT. So the question says that write the chemistry of recharging the lead storage battery, highlighting all the materials that are involved during the recharge. Okay, now this question is asking that if you are recharging, okay, recharging is important, not charging, we are talking about recharge. When you are recharging the lead storage battery, what is the chemistry of the lead storage battery recharging process, highlighting all the materials that are involved during the recharging process? Okay, now how can you answer this? So let's see. A lead storage battery consists of a lead anode, a grid of lead packed with lead oxide like PbO2 as the cathode, and a 38% solution of sulfuric acid as an electrolyte. This we have covered in our previous lecture about the lead storage battery. So, a lead storage battery consists of lead anode. It consists of a lead anode. Okay, the anode is made up of lead, that is Pb. A grid of lead packed with lead oxide, also a lead grid which is packed with the lead oxide PbO2, and this we will use as cathode, and a 38% solution of the sulfuric acid, that means H2SO4, we will use as an electrolyte in the lead storage battery. When the battery is in use, okay, that means we are using it, that means it is discharging. The following cell reaction takes place. So at the anode, as I said that if we are talking about a reaction of the cell, firstly we will talk about the anode reaction, then cathode reaction, and then the overall reaction. So at the anode, the reaction happening is lead is attaching with the sulfate ions which we are getting from the 38% solution of sulfuric acid which we are using as an electrolyte. Lead is joining with it, or lead is reacting with it and converting itself to the lead sulfate PbSO4, and we are also getting the 2 electrons as it is an oxidation process happening at the anode. Let's say this is first reaction. Now at the cathode, the reduction process will happen. So lead oxide, which is cathode is made up of, right? So lead oxide again reacting with the sulfate ions from the electrolyte and also gaining 4 protons and 2 electrons and converting to the lead sulfate, and also we are getting 2 molecules of water in this reaction. This is a reduction process happening at the cathode electrode, and let's say this is the second reaction. So the overall cell reaction is given by adding the first and the second reaction. You just take the lead, or you just have to cancel out first of all the similar things which can be present at the left and the right side of the arrow. Okay. After the cancelling out, whatever will be left, that will be present in our overall cell reaction. So lead will combine with the lead oxide and it will combine with the 2 molecules of H2SO4, because here we have H2SO4, here we have H2SO4. Okay. And we are getting PbSO4, PbSO4. So 2 PbSO4 plus 2 molecules of water. Okay. This electron will get cancelled out because one is present at left hand side and one is present at right hand side. Okay. So why we are taking H2SO4 as here as a common? So if you see, when you add these two reactions, SO4, where is the SO4 coming? Here in the anode at the left hand side of arrow, here again at the left hand side of the arrow. Also H positive is also present in 4 amounts at the left hand side of the arrow. When you combine them, basically H2SO4 is dissociating. If you dissociate the H2SO4, it will converts to 2H positive plus SO4 2 negative, right? Let's suppose we are taking 2 molecules of the H2SO4, so it will also produce 2H positive plus SO4 2 negative, right? Now if you join these two dissociating reactions, it will give you 2H2SO4 will give you 4H positive plus 2 SO4 2 negative, right? So if you have written 4H positive plus 2 SO4 negative at the equilibrium, because the dissociation reaction is at equilibrium, the reaction can happen in the forward and the backward direction also. So you can also write it as 2H2SO4. Okay. So we are already having 2 SO4 2 negative ions, which is this one, and 4 H positive ions, which is this one. And when you add these, and first of all, at the anode and the cathode reaction, we are writing them separately. SO4 2 negative here, because it is only the SO4 2 negative is needed at the anode. And at the cathode, we are writing both 4H positive plus SO4 2 negative because both are required. But when you are adding the anode and the cathode reaction, they can write as a whole as 2H2SO4. Okay, so that's why here we are taking 2H2SO4, and this is the chemistry of the recharging of the lead storage battery. Okay, highlighting all the materials that are involved during the recharging. So we have said already that the anode we will take as the lead anode and cathode we will take as lead packed with the lead oxide. Okay. Okay, now moving on charging the battery. Okay, now we have already seen a reaction during the use of the lead storage battery. Okay, use means if you are taking a battery and you are using it, that means if it is full charge, it will convert to the lesser charge, right? If it is full charge, it will convert to the lesser charge. So that was the reaction for this process. Now, when you charge the battery after the discharging, you can say discharging of the battery, when you charge the battery, the reverse reaction takes place, right? That is, lead sulfate, which is deposited on the electrodes, is converted back into the lead and the lead oxide. We are getting the lead sulfate, right? PbSO4 at the product side in that reaction of discharging. Discharging is not a correct word. You can use when you are using the lead storage battery, then that reaction was happening where we are getting the lead sulfate as a product. But after this discharging or after the using of the battery, when you charge it again, the reverse reaction will happen. Okay, that means the lead sulfate, which are deposited on the electrodes, is converted back to the lead and the lead oxide. That means the reactants which we are using while the reaction. Okay, at the anode and the cathode, remember. So this was the anode and this was the cathode, right? So we will reverse the reaction and H2SO4 is regenerated. So let's see. Reverse of reaction first, which was happening on the anode, will be reduction. Now that will be reduction. Okay. That means whatever the reaction which is happening at anode, that will reverse, and that will be the reduction process, because the electron will shift its direction, right? If at the anode the oxidation process was happening, that means the loss of or the releasing of electron was happening. But if you reverse that, that will become a reduction process, because the addition of electrons will happen in that case. So the reverse of reaction first will be reduction, and hence that will take place at cathode. So also the reaction place will also change. Whatever the reaction, that is first reaction on the anode was happening in the discharging process. Now in the charging process, the first reaction which was happening on the anode, now it will happen on the cathode, and the name was reduction. Similarly, the reverse reaction of the second reaction will be the oxidation, and it will take place at the anode. Okay, because oxidation happen on anode and reduction happens on cathode. So next question. So next Intext question is marked as 2.14, and the question says that suggest two materials other than the hydrogen that can be used as fuels in the fuel cells. Okay. So we are asking, or the question is asking, that we have to tell the two materials other than hydrogen, because until now we are talking about hydrogen. So other than the hydrogen, what are the two materials that you can suggest that we can use as fuels in the fuel cells? This you have to tell. So we have already studied about this, okay, in the theory, that other than the hydrogen, what we can use as a fuel in the fuel cells, or you can say in the galvanic cells, in which we perform the combustion of the fuels for the production of the chemical energy to the electrical energy, and then we can use this electrical energy as electrical power. So the answer is methane and methanol. Remember, CH4 and CH3OH. Okay, these are the two other fuels which you can use as a fuel in the fuel cell. That means after the combustion process of methane and methanol, a lot of energy you will get, and that you can convert to the electrical energy, and that you can use as electric power in various uses. Okay, so these are the other two materials, methane and methanol. Okay, so that's all for today's chemistry session.